Hassler here. So I want to talk to you about lesson 3.1b. This is just a continuation of the idea where we're going to balance equations by completing opposite operations on both sides. But instead of doing just two-step equations, we're going to include things like distributive property and combining like terms. In class, what we did is we worked in groups to work through solving these different equations. This is actually posted on Google Classroom, so you can go and practice this as well. But instead of me working through each of these, I'm just going to go ahead and do the check your understanding. And then once you watch the video on the check your understanding, I would like you to go back and try the equations in the lesson 3.1b, thin slicing, the Google slides here. Okay, and so we've talked about distributive property this year earlier in Unit 1. I know you've talked about it before in your past math life. And so just as a reminder, the distributive property means that we are going to multiply. And what we are multiplying is the number outside of the parentheses. And we're going to multiply that to each term. So I'm just going to actually draw my arrows underneath. We're going to multiply to each term inside the parentheses. And so I get 2 times 3, which is 6. There's an x with that, so I really have 6x. And then 2 times 1, which is 2. Equals, and I still have negative 10. So again, I like to draw my line when I'm solving equations. Drawing that line reminds me that I have this, really the scale that I'm trying to stay balanced or keep balanced. And in order to maintain that balance and in order to figure out the value of each x, that's the whole goal. The whole goal is to determine the value of each x. I would want to take away 2. And in those scales, we took away 2 blocks. I'm going to take away 2. And when I do that, I have 6 x's left. And then I have, negative 10 minus 2 is negative 12. So I actually have negative 12. And now I want to take these 6 x's and I want to divide them up so that I can determine the value of just one x. So I'm going to take the 6 x's and divide them into 6 groups, which means I'm going to take these negative 12 squares. I'm going to divide those into 6 groups. When I do that division, I'm determining the value of 1x. And negative 12 divided by 6, or negative 12 squares put into 6 groups, gives me negative 2 in each group. Now, we've talked in class about doing a check, right? I can always go back and check. And going back and checking means that I'm going to take that negative 2 and I'm going to put it in place of x in the original equation. So I have 2 and then parentheses 3 times. In place of x, I'm going to write negative 2 because that's what we found x to be, plus 1. And I want to know if this equals 10. So what I'm actually going to do is I'm going to come over here to Desmos. We've used Desmos together. And I actually can just go into the graphing calculator. And I can type that in. I can type in 2 parentheses. And then I have 3 times negative 2. And then plus 1. And when I hit enter, I see I have negative 10. And so that means that I found the right value of x. I substituted that value back into the original, and I got the answer out that I had in the original problem. So if I go back here, I got that negative 10. So you can always use Desmos to go ahead and type in your answer into the original equation and check if it's right. The other thing we have to deal with is this idea of combining like terms. And when we talk about combining like terms, we have to be super careful when we talked about this, right? Because again, I have this balance that I have to maintain. So when I combine like terms, I'm combining like terms on the same side of the balance scale. So combining like terms, we only work on the same side of that equal bar. And we use the given operations, not the opposite operations, okay? I only use opposite operations when I'm trying to remove things from one side, so I must remove things from the other side. Or if I'm adding on to my scale on one side, I add on the other side. But over here, I have these like terms, these 2 x terms. These are on the same side of the balance scale, so I don't need to do opposite operations. I don't need to do operations on both sides. I'm just going to collect them. I'm going to put them together and say, well, I have 4 x's and then I have negative 7 x's. So really I have negative 3 x's. I still have this minus 10 and then I have this equals 11. And now I can go through and I recognize that this is similar to what we were doing the other day, right? I got to know the value of each x. I got to get rid of the negative 10 x's. I do that by adding, I got to get rid of the negative 10 squares. I do that by adding 10 squares. If I add 10 squares on one side, I have to add 10 squares on the other. That leaves me with negative 3 x's over here and 21 squares on this side. I want to know the value of each x, so I'm going to divide by negative 3. I'm going to do that on both sides to maintain balance. Negative 3 divided by negative 3 just gives me 1x. That's what I want to know. I want to know the value of 1x, and 21 divided by negative 3 is negative 7. And so the idea here is that we're going to be doing these opposite operations, but only after we have either distributed or combined like terms. I call it cleaning up. We're cleaning up one of the sides of my scale before I can start applying these balancing acts to my scale. I'm going to come down here. I'm going to do problem 5. And so your job will be to practice 3, 4, and 6. And so if I talk about problem 5, it says determine the value of the question mark so that the equation is true. All right, so I have this question mark right here. And again, I like to draw in this line. I'm going to go ahead and draw in my scale. Right, I got to keep these things balanced. And just as a reminder, when we talk about this means that I have 5 groups of x minus 2. That's what that says. So if I have 5 groups of x minus 2 on this side of my scale, then that means that I need to equal 5 groups of x minus 2 on this side of the scale. Now, technically, there is a 1 in front of this. If no number is there, it's understood to be a 1. And so right now I have 1 group of x minus 2 plus how many more groups would I need so that this stays balanced? Well, I would need 4 more groups in order for this to stay balanced. And so this question mark must equal 4. Right? If I have 1 plus 4, that would give me 5 groups of x minus 2, and so my question mark would be 4. So again, your job is to try to maintain that balance and see what you can do in question 6. If you have questions, let me know.